this is the aforementioned controversial and visionary research, or at least I hope so. It's not a very traditional talk, so hopefully it goes up well. We'll see. So, this talk comes as the summation of the LSITS initiative, which is the Large-Scale Complex IT Systems Initiative, which was a major UK interdisciplinary, inter-university body lasting from around 2007 to 2013, had a £10 million UK government endowment, and investigated topics ranging from social technical problems, distributed system modeling, and so forth. That, as it progressed, it took cloud as one of its more main themes. And this is going to be a talk on the concepts and the difficulties that we found relevant to cloud computing research. So what I'm going to present now from the research that we've done is 5 pitfalls, problems that we think could limit cloud research, and then 5 opportunities that we think are different areas of cloud research that avoid the aforementioned pitfalls. So as time is short, we'll go straight into it. So the first pitfall I'm going to mention is infrastructure at scale. So specifically, what we're talking about is replicating scale. We see this in a lot of papers all the time, that we do experiments, I've done this too, where you attempt to replicate a small portion of a large-scale system, or you attempt to create an entire large-scale system through simulation or through modeling or through other means. And it's very hard to replicate that scale. Similarly, other attempts to do it are through actually building large-scale test beds, through going out and buying the equipment to put together large test beds. But it's very hard for individual universities to afford that. It's very expensive, it's very costly. Universities typically don't have dedicated sysadmin staff, they don't have researchers who are dedicated to maintaining those systems. So usually making test beds very, very hard. So we can't run our own exclusive large-scale systems. At least the average university often can't. So a second pitfall is abstraction. So this is a slightly more controversial point, that we argue that more focus is given to the physical infrastructure, the physical boxes, the low-level area. What we're suggesting is that instead of looking at the low level, at the virtualization level, at the physical boxes, is that instead we go up. We look at building on top of elasticity and look more at what we would term cloud research, which is stuff which is unique to cloud rather than something that could be considered virtualization or hardware or another field. So we would suggest a reclassification going there to ensure that cloud and other things are kept separate. So number 3, going through them quite quickly, is non-reproducible results. So this is something which is endemic in a lot of research, is relying on simulations which are untested or been unproven, that we don't necessarily know turn out real results that are verified, and reliance on trace data or private data sets that come from unknown sources, or at least unknown to the community, possibly known to the author, and thus preventing the community at large from verifying the veracity of the claims made in the paper. This means that while research in some papers may be very good, it might be cause for the community to investigate further, it prevents them actually using the claims made in the paper as a building block to go on to do further research. The evaluation can almost become null and void in some cases. So pitfall number 4 is rebranding. So rebranding is something that I think isn't necessarily unique to computer science, but certainly is fairly systemic in our community. And that is having the same problem, but then applying a different name to it. So this isn't something that happens elsewhere in the natural sciences so much, but in computer science, we typically have something. Say we have grid computing, and then we take some of the concepts from grid computing, and that transgresses into cloud computing. Well, certainly grid and cloud are not the same thing. The ideas move. And now we're seeing the shift from cloud computing to big data, and many of these ideas are moving along with them. This has happened many times. NoSQL is now just turning into something else. It's gotten SQLs back into it. The name is changing. So we're seeing that the venues, the papers, the titles are shifting, but much of the work is remaining the same. And this is changing the way that funding is applied, it's changing the way that we talk about things, but many of the core problems remain unchanged, and it's simply a changing of semantics that's the problem. And the 5th problem is industrial relations. There is often the case that we've observed through the LSITS initiative that there is a case of the have and the have-nots. That there are universities that don't have access to industrial data sets, industrial partners to get the knowledge, the data sets, the collaboration. This is potentially due to legal problems. I know Europe has a different legal framework for collaboration, and it also often occurs simply based on not having cloud. Smaller universities often find it quite hard to work with large industry bodies. And when a lot of cloud computing research hinges on the availability of large bodies of data, of trace data, of real-world data, it's very hard for certain universities to actually get access to it and do certain types of research, which is a significant limitation they have to do without or rely on other universities or collaborators to do that work. So that was a quick whirlwind of moderate controversy. That is points that we think are limiting cloud research. Problems that prevent us from doing certain types of research and potentially lower the quality of research that's done affected by those 5 points. But we propose that there is actually a silver lining, that rather than being doomed by those 5 points, there are 5 opportunities, 5 areas which aren't as affected by those pitfalls as other areas that are as yet untapped. So these are, so user-driven research is something that Ilsit was very keen on, something which is quite relevant today. So solving real-world problems is something which academics don't necessarily have to focus on. Certainly, the ivory tower and the thought of research for research's sake is something which is the basis of academic thought. But we have had some degree of a build it and they will come mentality, that if we do research, there will be users for it, which in some cases is certainly true, that users come and adopt research, but that's not always the case. So to avoid producing research that's potentially redundant or to produce better research, what we propose instead is to actually seek out people, seek out other academics, seek out businesses or government or other users and identify the problems that they're facing, and then identify how cloud computing and related topics can be applied to addressing these problems. So this creates a new class of research which is based upon the needs of users rather than simply research for research's sake. So a second opportunity is programming models. So this is something which is getting a lot of focus at the moment, and MapReduce is talked about everywhere. There's dedicated MapReduce journals. There is dedicated conference and workshops for MapReduce. It's very important, MapReduce, certainly. But there is more to life than MapReduce. Hopefully there's more to other things too. But what we propose is going beyond MapReduce, investigating different programming models, investigating other areas that have different semantics, different concepts. These might not necessarily be successful, but they are different. It's a sort of pioneering vision of going beyond what is currently available, rather than simply trying to refine existing semantics and concepts, which is a slightly more risky area, but is interesting nonetheless. So number 3 is identifying bugs in large-scale systems. This is effectively software engineering at scale in the cloud, to use as many buzzwords as possible in a single sentence. What academia has been very good at is founding software engineering, effectively, from working with industry in the very early stages and by themselves to produce disciplines, to produce a specification of how to develop software and doctrines of how to do it. And this is something which needs to be done for cloud systems, especially large-scale cloud systems, to understand the challenges inherent of designing big cloud systems, to talk about the difficulties of it, the theory, to how to build systems, rather than necessarily the practical elements of it. Go back to thinking about how teams can cooperate, the socio-technical elements of building better systems. This, we argue, is something that is very relevant, building or learning to build better systems. So point 4 is platform as a service environments. So platform as a service is something which has been somewhat neglected by academic research. Most of the research, to make a very starts generalization has been much lower down. It's been talking about the infrastructure level. We suggest looking at going higher up to design platform as a service environments which abstract away the infrastructure, which hide all the murky systems that everyone loves, and gives abstract environments which incorporate cloud properties, which do elasticity, which do all the sort of common cloud properties, but don't have to handle any of the murky low-level details. Again, this can be something which can be applied to other users, building stuff user-driven wise for industry or for government or for business, and building generic platforms, which is something that would allow us to ignore lower level things. And that is one of the pitfalls that we argue is dealing too much with the low level. We go up the higher levels of the stack. So, and the final opportunity is elasticity. So, many applications which are ported to cloud computing or run on clouds aren't necessarily built for these environments, so often adapted or changed. We don't necessarily know, in terms of things we talked about in the past, there, software engineering or in working with users, how to build applications that best exploit cloud topology, to exploit the properties of cloud. So with this, we propose to investigate building cloud-native applications, a mixture of theory and practice, to build and to do theory, to put those two things together and examine the implications of that, rather than solely examining. We propose building and then examining. So that has been a bit of a whirlwind tour. To summarize, we propose that there are points in cloud computing research which are limiting. They're pitfalls. They are areas which limit our ability to do research because of the non-availability of data sets, or the reliance upon per simulation, or non-reproducible results. And these can potentially limit our ability to do research. They can limit what we can do, what we can publish, and what areas are easy to investigate. But the areas that I've mentioned, of which there's much overlap between those 5 areas, are potentially areas where we can do research which is less hindered by those 5 pitfalls, which allow us to do good research less inhibited by those 5 aforementioned problems. The downside of this is that many of these proposed ideas have risk associated with them. As I talked about, the trends and the rebranding of computer science, trying to eschew rebranding can potentially have negative effects. They can potentially be out of vogue or otherwise not gain popularity. But risk is necessary in order to do good research. We propose it's that risk that's important, to take more risk and to branch out. So hopefully that's on time. I think it was quite fast, but hey-ho. Thank you. Hi. I can hear you. Yeah. Yeah, so that is one of the ways to solve the problem is collaboration. The UK has the National Supercomputing Centre, for example, that tries to solve. But a lot of the problem here is getting money to the right place and agreement between that. And often, yeah. Mm. Mm. Yeah. Yes.
I think for the most part, industry doesn't want stuff for free. They don't want the rights to whatever. They just want to know they're not going to get their asses sued, as
Mhm.
Apple has done for hundreds of millions of dollars recently by Wisconsin. So I think that's a really interesting point. That again, this is more just a general comment.
So as a flip side to that, from the academic territory, there's the reverse problem of industry having excessive sort of legal prerequisites to doing collaboration. It often puts off the average, grad student or a bunch of researchers if there's a stack of NDAs or other documents which have to be done.
My personal experience has been that the problem with it's bigger on the academic side. Big universities have big legal departments, and companies that actually will move quite quickly. They won't put NDAs in place if they just want to do a collaboration. And it's always been a lot harder to deal with universities. And this is not, I'm not,
Mm.
trying to do anything. It feels like I am.
As representative of all universities, I.
Nominated, delegated. All universities worldwide. Meet your new representative.
I shall take the crown.
But no, I mean, I think you made a lot of. I think the important part is recognize what's hard for universities to do, and things like platform as a service and so on are very constructive angles. So this was cool stuff. Thank you.
One of the things I'd like to sort of go on from that point that you made of sort of having massive legal departments is that if you've got the case of a small university or sort of aspiring university which doesn't necessarily have legal department or lots of resources, you could potentially get a chicken and egg problem of you need to have academic collaborators to grow and become successful, but to get the academic industry collaborators, you need to be large and have a large legal department. So it's a ordering problem that you have there.
Hi, it's Jonathan Napavu from Boston University. So first off, great name, so by definition, a good talk. So just to follow up on what Steve was mentioning, I think there's a couple of really important and salient points. So one, having lived on both sides of this world, having lived on an industry side and then going back to academia, I have to agree. Like, even though I am certainly an academic now, my legal department now is way more complex. And I didn't come from a small company either, right? IBM had its own legal barriers, but the academic side, we as an organization, I think really have to step up to the plate that this is a different world of research we're trying to engage in. And I think, so Steve was mentioning that, so we're trying this thing out, the Massachusetts Open Cloud, precisely to try to come up with a model so that it's not one industry partner, but somehow to come up with multiple universities and multiple industry partners to have something work. And I don't know that we will succeed, but I think there is this question about all of us moving forward. I don't necessarily think that the answer is to go ahead and put up more silos, that, well, academic research has to stay academic research and industry has to stay industry. Rather, I do think here we do have that opportunity now, have some shared data centers, and let's figure out the legal issues, because the world's going to do it anyway, and it is doing it anyway without us. So either we're all going to become obsolete, or we're going to try to move forward. So with that being said, though, I do want to raise one technical question. So with almost all your pitfalls, I was totally on board with. I love them all, except I've got to take qualms with one of them. So while I do concur that raising the level of abstraction is important, I think one of the big problems across the move towards cloud computing has been we are not acknowledging the fact that there is something radically different technically between grid, between LANs, between wide area systems. The data center scale physically is a different beast because we have a form of interconnect possibilities and technical physical changes. Computation and communication ratios are actually fundamentally different within the scale of a system within a data center. And it's actually, I believe, academics, we have to engage with each piece of research we do by saying, hey, wait a second, top to bottom, what might the implication be from what happens if the interconnect was flat? What happens if it was a torus? What happens if it were these things? What happens if you have RDMA? And I'm pretty sure there's some papers here about those kind of things. So while I agree, out of necessity, sometimes we do actually and should look at the greater abstractions, I think we should always be asking, what is the fundamental phenomenological difference here, and how does it reflect up and down the stack, not just sort of saying, well, we don't have access, so we just got to move up. Okay, now I'm done.
in defense of the abstraction pitfall, certainly what I'm not suggesting is that the areas below a certain level of abstraction should be disregarded, but perhaps that naming research which is below a level of abstraction as cloud research is potentially a misnomer. That data center level research isn't necessarily cloud research. There's, of course, an intrinsic overlap, but there is not necessarily that name relationship. Go for it. Go.
So I don't disagree. Like with all things, there is a distinction, but that's not to say data center research, there isn't cloud-specific data center research. I mean, exactly what we are seeing is that cloud computing, the reason it's having such an impact is that it really does question all layers and does ask us, well, look, it's very different. If I was an industry designing a data center for a particular type of customer set, that is very different than asking, what is the right cloud platform to host, to treat it really as a public computer? And I think there are questions there all the way down to, what is the right way of structuring a control network that simulates being air-gapped but has the flexibility? So, anyway.
Certainly, that could be the interesting case that when looking at the low level of abstraction, it's asking the right questions that is more pertinent rather than simply looking as below as possible and going into virtualization for virtualization's sake, or just going to the areas that are interesting because you can do them. But rather, when you're looking at cloud research, just specifically look at areas that are important rather than potentially just going across the board because you can.